Morning, Kishan.
Morning, Floris.
So today we're going to discuss a YouTube video and an article that has been written about the YouTube video. The YouTube video is from Sam Corcos, who worked inside the US Treasury Department. He has some ideas on software modernization, the concept of software modernization, and why you should not call it software modernization. So today we're going to discuss a bit about his ideas and opinions about the software modernization. It's about this one.
Fear that modernization or updating is just code for breaking stuff that already works but imperfectly.
So I have one of the other CIO memos that I'm writing is about why we need to stop doing modernization just as a concept, because I think it stems from a general lack of understanding of the software development process. This whole concept of like, we need to modernize, we need to throw a bunch of money one time at solving this problem and then never touch it again. I've analogized this to some friends of mine who are not in the software development space, where if you have two ends of the spectrum, one end is like building a house where almost all of the work goes up front. And then there's like this trickle of maintenance that comes afterwards. On the other hand is like getting a puppy, where there's some extra work at the beginning during the puppy phase, but you can't just not feed the puppy for like a year. You can do that for a house. You can just like forego maintenance, and it's not just going to immediately collapse. But software systems are effectively living systems that require constant maintenance and updates, where you get feedback from the people using it, and they say, hey, this thing doesn't work. Can you fix it? And then you fix it. And they say, hey, what if this thing was over here? What if it added this thing? What if it pulled in data from here? And you're adding to it over time. Our current software development process in the IRS, and this is another one of those things.
That was the snippet of the video where he discussed the difference between building a house and getting a puppy. I think in the sense of, can you maybe go in your reflections on that?
So I think it is a good point that he's making, that it's more like it's more intense than just building a house and doing maintenance. But there's always a middle ground somewhere. So there are situations where you can just build something and not touch it again and be done with it. But there's also situations that's more like a pet, that you have to do a lot of work up front and keep teaching it new tricks or new things to make it grow and make it more sustainable. It's as always, my answer is it depends. It's a scope between a couple of different types of applications, to put it like that. So if it's a very scoped and very limited set of functionalities that are pretty rigid and don't change, it rarely happens, of course, that this is the case. But there are cases that it does happen, where you can build something one-off and just do it similar like a house, the server maintenance or package maintenance, to just make sure that you don't have any, or that you address any open patch issues or vulnerabilities in the underlying frameworks or applications that you use. Maybe an example would be a piece of software that does one thing and one thing very well, but that's the only thing it does. If I have to think of an example of something that we did, it might, well, as I said, it rarely happens that we build stuff that just does one thing and we never have to touch again. But I think one of the things that we built in the past was an import automation system. We built there were a set of Excel files that were used for years and years in the same type of process, that were sent to an email inbox, and they were handled by a person basically copy pasting everything into 2 or 3 different underlying systems. Those systems haven't changed in the past 5 years, and they weren't changing in the next 5 years as well, because of contracts and the way those systems were procured. And they wanted to basically automate the part of copy pasting the Excel files to the different systems. The way we did that was, okay, we knew we had to build something that would work for 5 years, and then after that, they could throw it away because they would need to do new procurement of new systems, and the whole process would probably change. I wouldn't really call that modernization. Well, it's a part of modernization. It makes the process more modern and less, reliant on human work, but it's more of an automation process in that sense. But we built a piece of software that would ingest the Excel files and the attachments they would send, like they sent the past 5 years before that, to an email inbox, grab those files, scan them for malware and any other vulnerabilities, and then basically go through them, collect the different data sets that we needed to collect for each system, and push them downstream to the different systems. And that system is still running until this day. And the only thing we basically had to do in the past few years that this is running is updating the server software and making sure the packages are up to date. We didn't really have that many dependencies except for the malware scanner and the Excel library we used. But that's basically it. So there are cases that you build something, the only maintenance you have to do is basically maintenance to keep the thing from breaking down or for being vulnerable. The similar, like you have to, do your paint every couple of years, or you have to wax your floors every couple of years just to not make it break down. It's similar like we had to do there. So there are use cases where you can build something one up and not touch it anymore. But they are, as I say, very rare because the scope has to be very controlled and you have to know upfront that it won't change for the next couple of years. Most of the software projects that are being built, of course, have people using it, people have changing wishes and changing software around it that they use. So integrations need to be built, people's preferences change, the landscape changes, maybe different vendors are, onboarded to do or change a system that was already in place. So there are a more diverse and changing ecosystem in reality.
I suppose it is also difficult for product owners or founders to estimate the cost upfront. How much effort and thus time and money will it take if you now are going to build a product, and then what do you need to reserve after the initial release? Like, in a sense, that is also sort of a business case that you have. I suppose that you say, okay, we launched a new product or a new platform, and if you either say we're going to lock it down, don't do anything about it except for the security, and maybe some small updates. I think that is a business decision probably that you take. Also, you can ignore required updates, new features, UX things. You can ignore that, even upfront think about ignoring that and accepting that, as maybe the IRS does apparently in the US, that just say, okay, we're going to launch this system, we keep it 20 years, we don't do anything about it. Is that like, what are the tiers? What are the different scenarios from not doing anything except for updates all the way to really having a full development team also on the product, staying on the product to, for example, be one step ahead of competitors, because that's a good reason, I suppose. If Anthropic or OpenAI now stops development, they are irrelevant within 2-3 months. So there's a good reason to have the development teams doing ongoing updates and new features and UX things and all these investments that they need to do. So there's a very good reason for that. And there are very good reasons to do nothing, to just launch something and then do only the security updates. What are the possibilities in between? Like also working with an agency, for example, to have some minor features added, some of like twice, 3 times a year. What do you see as scenarios in this case?
So the scenarios, there are basically 3 different ones where, as a developer, you would normally advise to do the latter scenario, which is keep doing incremental development and continuous development, so you don't incur any technical debt, or you have to do major, big bangs every time. The spectrum basically goes from there is of course a doing nothing, but doing nothing is, I think, outside of scope, because in software, if you do nothing, basically your risk appetite is huge, because as we all know, vulnerabilities come out every day for any type of software. It's kind of impossible to build software without any dependencies. Even if it's just on a server level, you have dependencies, so you have to keep things up to date regardless. There is, of course, a risk appetite to not do anything, just deploy it, don't touch it forever, but that's basically creating a honeypot, so I wouldn't put that in the scope. So option 1 would be, as I made an example, we build something and you just maintain it for the minimum amount of maintenance, which is security updates and patches. That's all you need. You don't do any incremental updates, you don't do any changes, user requests, nothing. You basically lock it down. That's the thing we're going to serve, and the only thing we're going to do is make sure that it cannot be attacked. The middle ground would be doing multiple incremental developments over time, but not as a not as a dedicated development team, or as some team that is owning the software for the whole period of time and maintaining that based on user input coming in, maybe performance indications that things need to be upgraded, or updates coming in from the security scans that you do, or other upgrades from packages that have new versions. Then you would basically create multiple iterations where you incur debt until you plan a new iteration. Then you would have to resolve that debt, which of course is more time spent upfront to basically get the version and all the functionalities up to par, and then develop on top of that again. So you're basically incurring debt, you have to work that down, you have to upgrade everything, and then that's your base you're going to start developing on again. And then you deploy that is the version you're going to use. And then the next development will be planned whenever the client or company wants to do something again. But then the first thing you would have to do again is remove all the technical debt that you incurred. So do all the security updates, do all the package updates, make sure everything is again up to standard, and then develop on top of that. We rarely recommend that, because it's you have to spend a lot of time. It's not that you don't spend the time, you spend the time staggered. So instead of keeping the application up to date because you have some kind of SLA or security update agreement, you do it before you actually do the feature development that you want to do, because you need to have certain updates in place to not have a vulnerable version that you keep on incrementing upon. And the latter one is, of course, the best way of developing is keeping, addressing technical debt, addressing updates with every iteration that you do. So continuously, every sprint, the first thing you do is update everything, and the end of the sprint, before you deploy, you update everything. You keep everything updated, you keep everything in check. If there's any package that is deprecated, you replace it with the next best thing or the next recommended thing. You make sure the servers are up to date, but that's an ongoing thing. You make sure that you are at the latest versions of even long-term service versions of applications. They get out of scope at a certain amount period in time, so you have to upgrade anyway.
What like, from a real world experience, I suppose these three scenarios are like, that's how you could look at it. But if you look at the real world experience that we have, and when clients come up to us and say, okay, we have an outdated product, we worked on it, we built new features, but we still have PHP 5 as in our system. How do you? So I suppose that they then ignored the technical debt, continued building on the then outdated stack. How do you look at that? Because that, I suppose that is a risk appetite is significant in that case. That's for one, but I suppose that happens a lot, this example, right?
I hope it doesn't happen a lot, but we see it happening, yeah, in some of the work we get along. As I said, it would be somewhere in between the first and second option, but it's the worst of both worlds. You're basically developing with your hands tied behind your back, because it can break at any time, but you don't spend the time to make it more robust or more up to current standards. So you're basically piling work on top of a very brittle foundation. And it may not be that the code is anything wrong with the code, but as in your example, you use PHP 5. That is proven to be one of the worst foundations you can build something on if you didn't keep it up to date. Because right now we are at version 8 point something. I mean, that's you're behind by a lot. You have lost support for the past, I don't know, 10 years. People don't even know what's wrong with it anymore, because nobody exposed any information on any vulnerabilities, because nobody supports it anymore. So even if vulnerabilities were found after the version was out of support, you wouldn't even know.
I suppose that is something to warn people about, but then again, I think there is a lot of software developed like 10, 20 years ago that still is in production today that might be in, or at least maybe people then invested money in it and hope that it would be as a house, small maintenance, don't do too much about it, don't do too much work on it, don't invest too much money on it, and just get the returns from the initial investment. And I suppose today, or at least as we look at it today, is we need more of a perspective on, okay, we have an initial development budget, and then we have a maintenance budget, and maybe even hopefully also like a budget for new features, UX integrations, and that kind of thing. I think that is to look at that from that perspective and make a business case for that scenario. I suppose we agree upon on that fact, right? Or
Yeah. I mean, there is there is no. I mean, in the past it was going a lot less fast. That's the thing. Software right now, the whole landscape is moving very fast. Not just because the whole AI thing is going fast, but also the AI supported tools and bad actors and good actors, of course. People find a lot more vulnerabilities using these tools, because you can automate a whole bunch of stuff and do it a lot faster. So the landscape moves a lot faster. A lot more vulnerabilities get found. So you need to be you need to be responsible to upgrade those applications, because if you have user-facing data, I mean, which almost every application does, you have to keep your users secure and your user data secure. So the only way to do that is to keep incrementally updating these things. And
do you see the opportunity or opportunities to automate or automation in removing the technical debt?
Well, it depends what you do. There's technical debt in things you can measure with security packages and upgrades. So that's one part of it. But most of the technical debt you cannot really measure is implementations that you could have done better or could have made more robust, because you know that you have to do future changes on that same part of code. It's basically, you write a piece of code that probably works the first time, but it's not the most efficient way of doing that piece of code. So if you keep that in place your first iteration, it probably works, but you have to rework it every time you touch it. And that's the more thing with technical debt, is that you want to keep touching old stuff, because the more old stuff you touch, and if it's isn't covered by any test, if it breaks probably more than you know in your application. So that's more of the technical debt that you cannot really measure just by doing automated tools. I mean, AI can measure that now, because it can scan your whole code base and make assessments of what things are probably best to refactor. But the very simple thing of keeping up to date is scanning your package files, your included libraries and dependencies and scanning your server software to make sure that you are up to date. And if you're not up to date, that there are paths to automated updates if it is lower version updates, and that you get notified if you need to do a major update and the reason why.
Suppose, can you put a factor of how much more work it would be in these two scenarios that I'm going to sketch? So suppose you have built like 10, maybe 15 years ago, a product with PHP 5, and you do minor security updates, and maybe sometimes you ignore updates, opposed to someone who really does everything to keep up to date and even future-proof his or her product. How much more work would it be for, or maybe I'm going to give that the direction in the question. If you keep your PHP 5 opposed to keeping your product up to date and do everything as it comes out, how much do you need to refactor or rebuild everything if you get up like that now in front of you because it's so outdated?
Yeah, I mean, if you're talking about PHP, it's a massive difference in what the capabilities of the language were. I mean, 5 was, I don't know, what's 13 years ago? I don't even know, long time ago in where we are now. It's a very different world. Not only security-wise, but also performance-wise. There have been tons of different performance and developer experience upgrades in these versions to where we are now in 8.3, I think, with regards to 5 point whatever that application you're talking about is. Not only security, but performance, connectivity, and developer experience. I mean, developers can work so much more efficiently with modern software versions than older software versions. It's not only PHP, it's also JavaScript, it's also Python, it's C#, it's Java, anything. Basically, every language, especially a language version, you would need to keep up to date if you are maintaining or keep building on the application, because it not only makes the security posture of the application better, but also the whole experience of developing and keep building on top of that application. Yes, it is work you need to do, but it's work that makes everything more efficient and more robust.
You mentioned it a bit already, but now with the LLMs and the capabilities that they have to build new products, internal or maybe even external. Obviously, when you launch a product, then it comes with a cost to maintain and further update that product. How do you look at the buy versus build line of thought How do you look at the buy versus build? If you, for example, buy something, then the provider is responsible for maintenance, security, and maybe even updates to the program. And obviously they have maybe tens or hundreds of clients, so they can be more efficient or effective in everything that they spend will end up at like 10 or 100 clients. So that would be probably a good return on investment that they have, opposed to building your own products. Then you need to do the maintenance and the further development yourself, obviously. So do you see also with the rise in LLM generated applications that probably, or maybe even certainly, these maintenance and future updates that are required are maybe even forgotten by most people that introduce these new products?
I think a proper developer or a development team would not forget these things, right? These didn't change because LLMs became more capable. It's always been a case, whether you build it by hand, whether you build it AI supported, it doesn't really matter. You would need to keep maintaining and updating your software, left or right. So I think the issue arises with people that are not developers or are not technically minded, that can also be putting out these things very simply. Those are introducing a new attack vector and a new security, I wouldn't call it issue. Well, it's kind of an issue. There are many more incidents now that people are able to spin up applications without any technical knowledge. Let's put it like that. And that's because, as a developer, you're trained to have a certain mindset, security, by design, and you know about certain attack vectors, you know what to prevent and what not to prevent. And LLM also knows that, but without any input on how to set up the security posture or of an application, or what your risk appetite is, or what you do and do not want to do, it just does it the most straightforward way, which might not be the most secure way. And as a non-technical person that can also use these same tools to just spin up whatever, for example, if you want to connect, or not connect, if you want to set up a simple dashboard right now, you can just go into, I don't know, Lovable, V0, Replit, whatever right now, connect your company database, assuming you have access to these tools, and just ask the AI, hey, build a dashboard for me. It will build a dashboard for you. But you wouldn't know what it does. You didn't know where the data goes. You wouldn't know what queries it does. If you say deploy this for me, you don't know anything about what it actually does with your company data and how it's exposed to the outside world. It might be secure, but I've also seen many applications where access keys are just stored in the front end because a user doesn't even know the difference between a front end and a back end, and because it doesn't know what to steer the LLM on, and the LLM just builds a dashboard for them. And if you and I will access that dashboard, we would be able to grab all their company information from the database because the access key is right there. So it's not a question of can we not do it, and is there less or more technical depth. It's more the people that are able to put these things out are not necessarily the people that know the most about how to securely do this, which we talked before about the whole shadow IT. This is not even in the shadows anymore. This is just public sharing of things that shouldn't be public.
And like, from your experience, and not looking only at the internal tool or maybe tools for internal use, as you just described one, and those are, I suppose, they introduce new attack factors, but I suppose they could be minor security leaks up until very big security leaks. But looking at maybe a bit of a bigger picture in the sense of, and from your personal experience, you're the CTO of Eli 5, you have, and your team has like a lot of different products under its wing, developed tens or dozens of products the past years, and for some of them Eli 5 is still responsible in maintenance. Is there a way, maybe even a fancy way, asking you as like a developer that doesn't want to waste time, is there a way that you have like an overview of all these applications and their state, so to speak, in the sense of not only security but maybe also even what the wishes are from like the customer perspective, if they want to keep on updating this product, or that they just have sort of a freeze and only do the security things? How do you look at that like overview? Or because it can add up, like if you can maybe even have like 20 products that you have responsibilities for.
Yeah, but we at Eli 5 don't really involve ourselves in long-term, we don't want to be the ones that forever build your applications. We want to do the heavy lifting, and then we work with the internal development teams to hand over the software to the internal development teams using our methods of working and what sharing all the knowledge we have done up until that point. So we don't actually know for most of our products what the current development team is doing because we're not in contact with the development team anymore. We're in contact with the owners of the company, but they have their own development team and their own responsibilities right now. But let's say that was not the case. If we would still be involved as the main responsible people of all our applications, we have dashboards that show all the applications we are currently developing or maintaining or are in any way involved in, that have pretty significant logging and application monitoring for both server and application to show us everything. So yeah, if we are involved, we connect all our applications to these APMs and logging softwares that give us insights into the whole scope of the application, from the a user entering the web page onto it reaching the server and giving something back to the user. We have all the traces for that, and we monitor those, because that's also when we are involved, we try to optimize continuously. So we need to monitor the applications that we are working on to know where we need to improve. Like as I said, we don't want to do one-offs unless it's absolutely necessary or a business decision that it makes sense to do, like in my example for the 5-year scoped one. But most of the applications we are involved in are continuous development, so we have to continuously monitor and improve and see if there are any bottlenecks and resolve those. That helps us, reduce the technical debt.
Right. Okay, and last question on this topic then for today. Like, suppose there is a new software modernization project. We just call it still software modernization, but there is a legacy system that needs to be rebuilt or refactored. I suppose we need to ask the question to the owner or product owner, what is your purpose, your future purpose with this product? Because you can still make the same decision as you did 20 years ago of building it and not touching it, only maybe doing the update. So I suppose also in our software modernization activities, we need to still ask about the business case and the requirements for the future, if it needs to be continuously updated and monitored and all these things, right?
Yeah, but I think nowadays there is no business case that is viable anymore for building something and not touching it forever anymore. I mean, the world doesn't work like that anymore. It's changing too fast.
Then I suppose that you agree with what Sam mentioned as not referring to modernization as a concept anymore because it doesn't exist anymore.
Well, I think modernization just says make something more modern, so it doesn't really have any bearing on not touching something, doing one-off. That word doesn't say that. But I mean, I think the connotation with software modernization has been, hey, I have something old, I upgrade it to something new and be done with it. But that's the thing, words and meanings and definitions change as well. Software modernization in the year 2026 shouldn't be, doing the one-offs anymore. It should have, always should have been making things maintainable and secure, and keeping, making the software more modern and keeping it modern. And modern not being the latest and greatest bleeding edge technology. That doesn't necessarily mean modern. Modern just means up to date. Up to date can also just mean, hey, we don't make it anything fancy. It doesn't have any AI connectivity or whatever, but it is the latest versions and the latest security updates of the application that we can support. So we know for sure, well, at least, I mean, you don't know if the packages are vulnerable until a vulnerability has been found, but at least you know you have done everything in your power to make it not explicitly vulnerable.
I think we're going to write an article about these different options in making your product, keeping it up to date or modern, all the way to really going all in on the continuous development of the product. I think that is helpful for our listeners also and our clients. So I want to thank you today for your insights and experience. Thank you, Kishan.
Thanks, Floris.